AI technology is advancing rapidly, yet industries face increasingly complex challenges that require sophisticated solutions. For example, in healthcare, AI agents are now capable of managing patient data at unprecedented scales, enabling faster diagnostics and personalized treatment plans. Building on the need for advanced AI agents, we now turn to the significant challenges facing AI deployment today. Scalability remains a primary concern, as AI systems often struggle to maintain performance with increasing data volumes and user demands. Ethical considerations, such as ensuring data privacy and avoiding bias, are critical as AI tools become more ingrained in decision-making processes. Furthermore, integrating AI with existing technologies poses compatibility issues, often requiring substantial updates or overhauls to legacy systems. Addressing these pain points is essential for realizing AI's full potential. Building on the challenges of AI deployment, let's delve into the core architecture of AI agents. These agents are designed to independently learn from vast amounts of data, continuously improving their performance over time. They possess the unique capability to adapt to new information and evolving situations without explicit programming. This flexibility enables them to perform an array of tasks, from data analysis to complex decision-making processes, making them indispensable across various industries. Building on the core architecture of AI agents, let's explore a practical example. We'll demonstrate how to implement a basic AI agent using TensorFlow. First, we define a simple sequential model with layers to process data and make predictions. Here, we utilize a dense layer followed by an output layer, and compile the model with an Adam optimizer. By training this model on a sample dataset, the agent can learn to classify data accurately. This hands-on approach exemplifies the practical adaptability and learning capabilities of AI agents. As we delve deeper into AI development, it's crucial to recognize and rectify common pitfalls such as data overfitting. Overfitting occurs when the model learns the training data excessively, losing generality. To counter this, techniques like early stopping monitor the validation loss, ensuring we halt training before overfitting begins. Additionally, selecting an appropriate model size and properly estimating computational resources are vital steps to optimize performance and efficiency. By addressing these factors, you pave the way for creating robust and scalable AI solutions. Building upon strategies to avoid common AI pitfalls, let's summarize the immense potential AI agents hold for the future. By 2026, AI tools will significantly enhance productivity across industries, driving innovation and efficiency. This transformation invites you to experiment with AI technologies yourself. Subscribe to stay updated on the latest advancements, and I encourage you to share your experiences or questions in the comments below.